Section 4.7 is the last section of this chapter. It talks about, it's on page 269, talks about the cross product, and we start off with a definition of what the determinant of a 2 by 2 is. Now this idea is going to be enforced in the next chapter, chapter 6, heavily, but for now we're just going to sort of reduce the 3 by 3 by memorizing this one formula, but once we get to the next chapter, we'll really elaborate on that and do a bit more. So there we go. If I look at a matrix consisting of 4 entries, the determinant of the matrix is the product of those minus the product of those. And I'd like to pick a few problems on page 273. I start off, and again, notice the notation for a matrix really looks like this. But when you talk about a determinant, it looks like absolute value or the magnitude of a vector. And that's not a coincidence. But for now, let's just find it. So find the determinant. If you put an absolute value, that's the determinant is. That is negative 2 times negative 3, which is a 6, minus 2 times 5, which is a 10, and that will be a negative 4, and that's pretty much it. For a 2 by 2, straightforward. How about if I wanted to do this? That's a negative 12 minus 0. That turns out to be a negative 12. Now, if I get to a 3 by 3, we have a problem because it doesn't match the 2 by 2. So what we do, we reduce it. Now, something to keep in mind on how this works. If I look at the first entry A, the second entry B, and the third entry C, what I do, I pick each of those. In this case, we're going to pick this first row. Always. When we get to the next chapter, you could pick any row or column. For now, just that row. If I pick A, so what I'm doing, I'm reducing this. If I picked A, I'm crossing A's row and column, meaning I'm going to go to A, I'm going to cross the row and the column. What that leaves me with is a 2, a 4, a 1, and a 3, right? When I get to the B always picks a minus. That middle will always take a minus. And if I cross B's row and column, I'll notice that what's left is a 0, 3, and a 4, 3. And if I get to C and cross C's row and column, I'm left with a 0, 2, 3, 1. And that's pretty much how you find the determinant of a 3 by 3. A times, and we know how this works, 6 minus 4, that is twice A, minus B times 0 minus 12. Negative times a negative is a positive. And for C, we're looking at 0 minus 6. That would be a negative 6C. And that's basically it. So for a 3 by 3, 4 by 4, we reduce it, but we don't do 4 by 4s now in this class. I want to pick another problem, and I want to tackle that. And if I do this again, I'm going to take A. I'm going to say the determinant is A times. And this is kind of how you start doing this. You do automatically a 4 minus a negative 6. You get to the B, and automatically, there's B. You say a negative 2 minus a 0, and you get to the C, and you would take a 2 minus 0, and don't forget the middle will always pick a minus. So basically, again, you could do this any way you like, any row or column. For now, we're going to stick with this. That's going to be a positive 10a plus 2b plus 2c. And there it is. It turns out a big formula that we really need to know that has a lot of applications states a given v to be the vector a1, b1, c1 and w be a2, b2, c2. Those are two vectors in space. The cross product written v cross w is this mess. And we notice this is very hard to really memorize. Instead, we develop a nice trick. V is A1, B1, C1. And W is A2, B2, C2. So when we say we want to find V cross W, the way to do it is really to think of I, J, K, write down the first vector in that order, and that would be A1, B1, C1, and the second vector in that order, A2, B2, C2, and if I find the determinant of this, I'll notice there's the I, and if you remember how this worked, B1, C1 minus B2, C1. And if you remember, the middle will always take a negative. A1, C2 minus A2, C1. And if I go for the K cross A1, B1, A1, B2 minus A2, B1, and if I glance at really what we have found, I'll notice that this right here is this right here. And if I distribute the negative in, then this right here with that negative is actually right there. And if I look at the last piece, it will be right there. A1, B1, I, J, and K. So this is a quick way of finding the cross product. Now, what's the cross product used for? We're going to barely touch on it in this section. You really hammer this down in third semester calculus. You really master what this does. It has a lot of applications. So on number 16, I'm supposed to find those four cross products, and it's a good practice. There's V, there's W. If I want A, I want V cross W. What I'll do, I'll write this as I, J, K, list VW. The order is very important, and W after, and I'll notice this is going to be I 12 plus 4 negative the J negative 4 minus 6 and the K component would be a 2 minus 9. And that's basically it. I got this. So the cross product of those two would be a 16, a negative 10, and a negative 7. A quick correction. This was a negative 1, not a 4. My mistake. Negative 1, not a 4. So that would make the first product negative 3. And that will fix that to be a negative 1. And when you go for the second, that will make that a 1, not a negative 4. And that will make this 5. If you've got to go home, try this, and it's not matching. This is a, if I go for B, B would be W cross V, W cross V. Well, I, J, K again. In this case, I'm going to list W first. And that would be, if I go for the I, that would be negative 4 plus 3. That is actually a negative 1. If I go for the J, always a negative. And that would be, oh, come on. That would be 6 minus 1. That would be negative 5. And if I go for the K, that would be 9 minus 2. That would be a 7. And there it is. I'm going to finish this on the next video because I'm running out of time.